One topic that I found to be a challenge is the mechanism for the formation and opening of epoxides. So epoxides are three-membered rings with one oxygen, and it's formed from an alkene with peroxy acid. This topic was challenging because there's so much movement of electrons in it that it's kind of hard to keep track of. To overcome this, I guess I just wrote it out a bunch of times, which helped me remember it rather than just seeing it, actually writing it out. So I'm going to show the mechanism for the formation as well as opening it with an acid versus a base. So here we have the movement. I like to start here with a double bond because it's easy to remember because there's just one double bond in the peroxy acid, and it's from the C to the O, one of the O's. So an electron pair here goes to the hydrogen on the molecule, and then from this it has too many electrons, so this bond, the two electrons in this bond, go to one of the carbons on the alkene, and then one of the electron pairs from the double bond in the alkene goes to the oxygen that was attached to the hydrogen in the peroxy acid, and then the electrons in the single bond from the two oxygens goes to form a double bond between the other oxygen and carbon. And then the product of this is this three-membered ring with oxygen, and since the stereoisomer is the same as the starting alkene, we have a cis isomer since it was cis up here. Then for a base versus an acid, it was hard for me to keep track which process did SN2 first and which process did protonation first. So the base, which is if you use water and hydroxide, we'll do SN2 first. So you can see that here, the SN2 reaction, and then after this we're still left with an oxygen that is not an alcohol, so we have to protonate with water since we obviously can't protonate with hydroxide. And then we form this, and then for an acid we do the opposite. We do protonation and then the SN2 reaction, because we have a hydronium that is willing to give away its hydrogen readily. So we have this here, the protonation, and then after the protonation we have the SN2 reaction with H2O, and then we have one extra hydrogen, so we deprotonate and we get the same product. So two other difficult concepts that I came across were understanding which conditions will favor elimination versus substitution, and whether it will be two-step or one-step. And I also found hydroboration to be difficult.